And 3, 2, 1, go. Hello, it's Keith here, and this is my first live stream. Now, I'm looking at my counter and it's showing there's currently 3 people viewing. However, I have a nasty suspicion of 2 of them are me because I'm watching on the preview screen and I'm running my phone so I can test the audio. Okay, well, what are we going to be looking at today? Well, what I've got here, of course, is AkuSprite editor. So I've been doing a bit of work on this over the last few weeks, and I thought it was a good thing to maybe have a bit of a discussion on, because it's something I've done a lot of work on, so there's some stuff we can have a look at what's happened recently. It's going to be having a lot more development work going forward. I'm hoping maybe to start working on the code, putting some better comments in and tightening it up, because it's really quite sloppy at the moment, but it does work. So anyway, that's the kind of things I've got planned. Now, first of all, I just need to discuss some of the current features that have been added. Well, as you can see from the top menu, we've got lots of new options up here. So I'm splitting everything out by processor just because it's an easy way of making everything nice and clean. So you can see here we've got the processors now, 6809 ARM and TMS. This doesn't do anything yet, but you know, we're going forward. Something that's quite curious with the software these days, though, is it now supports so many different systems that actually when I add a new one, often I don't need to do any coding at all, because a system like the Spectrum Next uses actually the same graphics format as the MSX for its 4-bit per pixel mode. So I'm kind of in a luxurious situation now where I can support new systems without coding a single thing, and that's part of the reason I'm saying I want to start condensing it down, because really some of the code is duplicated in places, and I'm thinking I can start to create kind of super functions that can do a large number of different functions, like exporting an entire screen and exporting a 16 by 16 tile could be done by the same code, just depending on how you break up the screen into 16 by 16 chunks or full-size screens, for example. I know that maybe is a poor way of explaining it, but as I say, that's the kind of thing I'm thinking. It will make no difference to the functionality, but if someone were wanting to take this and extend it, that would make the code a lot simpler for them to work on. So anyway, that's maybe something I'm working on. Now, up until very recently, AkuSprite editor was a 16 color editor. It got our 16 color palette at the top. And I mean, to be honest, it's still intended to be a 16 color editor, but going forward, it's not enough anymore, because I'm now supporting the DOS systems. Got over 8-bit here, VGA, so that's 256 colors, and also the Spectrum Next and the X16. These are 256 color systems. So I kind of bit the bullet, gave in, and upgraded it. Now, fortunately, the way it worked internally was always using byte structures for the color palette. The reason for this was, if you look up here, we've got 16 colors and 1 extra. The reason for the 1 extra is it supported a transparent color. So it always supported values from 0 to 16, so 17 in total. So I was already using these byte structures, and that gave me the potential to push it all the way up to 0 to 255 without rewriting everything. But I did have to rewrite the palette code, because the palette colors were being selected from up here before, whereas now it's being selected from here and this extended palette down here. Now, if we want to change a color, we can just click Set Pal, and we can either click on something up here or click on something down here, and it will bring up a palette for us to change a color. So we've got some options up here now as well for palettes, and we can use default palettes. There's the VGA one, which is something like that. I'm not sure that's the true VGA one. I just pulled that off an internet site because I needed a generic file to start from. Now, the Enterprise uses this color set, and you'll want to use that if you're exporting for the Enterprise in 256 color mode. The layout's different. I reorganized it. If you convert your 0 to 255 to bits and then run those bits through the color definitions that the Enterprise uses, this is very confusing and very hard to use. But I thought I'll reorganize it to a way that's much more human readable, because the exporter converts from the color values anyway, not the actual byte values held within the data structures. So making it neater for the user made it a lot better. But my personal favorite is this one that I came up with. Where's the option here? And if we go for this simple 4x4x4, so this works on a 4x4 grid, and then you've got 4 of those, and then you've got 3 brightnesses, and that left a spare bit up here. So I've used a standard sort of VGA 16 color palette here, shades from black to white, and then this is skin tones. I figured that if you were going to do something just general purpose, the human eye is very good at seeing skin tones, and they start to look ridiculous if people have got orange skin or purple skin and things. So I thought giving a full 16 colours of skin tones and a full 32 of grayscales is going to give this more potential. So I find that quite interesting. So the colour palette's been upgraded. The 256 colour support is now in there. So that's all new stuff. We've now got a flood fill function. Maybe it even works. Yes, it does. So I'd been putting off doing that for ages because I honestly couldn't entirely work out how to do it. So I had a look online, and yeah, it's basically a nested function where you have to look for spare pixels that need filling and then run those through a subroutine, or actually I push them onto a stack, because even the wonders of C# were struggling with really heavily nested subfunctions. So that's why I've done that. So anyway, AkuSprite editor is, say, my kind of my pièce de resistance for the programming series. It's still very basic, as I've said sort of before. The intention is really that if you're looking to do very advanced stuff, you would do an edit copy to clipboard and then paste into another graphics package. Like I tend to use Critter because it's free and it's very good. It's I'd say it's about the same level as Photoshop was back in the CS2 days, which for my standards is superb. And as I say, the fact it's free means you can use it on all your machines. You can use it home and work, and you don't need to worry about online activation or monthly subscriptions, which is, I believe, the new thing they're doing these days. So I would totally recommend that. So there we go. Now, I'm generally progressing through these, adding more and more functionality to all these options as it comes up. A lot of them now have save raw bitmap and save sprites, because a lot of these systems have different data structures for the sprites, and even in some cases where they don't, like the NeoGeo, you want to split a large image up into chunks so that you can export it as sprites. So if your image is 32 by 32 on the NeoGeo, you want to split it into 16 chunks and then work with those there. So that's something I'm working on these days as well, is just trying to make the functionality more advanced for a serious user of the software. So if we just have a look, for example, at the NeoGeo, this machine, I apologize for the speed of this machine is not fast. I'm not using my normal machine because my normal Windows 7 machine I don't put onto the internet, so I'm using a tiny little Windows 10 machine. It's literally little bigger than a Raspberry Pi, and its pitiful Celeron processor is struggling under the weight, shall we say, of this stream. But yeah, it's doing okay. I've had to mess with the settings, but I've turned on hardware encoding, which miraculously this system seems to support with its integrated graphics. But it's doing okay. 14% encoding, which is quite adequate, and I've got a preview running on my other screen as well, so can't complain. Can't complain how it's doing. Anyway, so let's have a look at NeoGeo here. Come on. And then if we go to save sprite here, so this is the code that would save the sprite. Now, if we just go to ChibiAkumas.com, so what we're going to do here is we're going to look at the documentation on the NeoGeo. NeoGeo here. So if we look all the way down here, that's not our sprites, where are they? Here we go. So the structure of the sprites, as I mentioned in a recent tutorial, is pretty weird, really. Essentially, we split this image up into 16 by 16 squares, but then we go down the right 8 pixels first, and then down the left 8 pixels, and we save into two separate files. Bit weird, really. That's what we have to do. So you'll see this represented in here. So we've got a load routine here to select the file name that we want to save to, and we're specifying a C1 for the first ROM file, and then we're converting that C1 into a C2 for the second ROM file. We're opening two binary writers here for saving binary data, and then we are going through the size of our sprite, because this supports sprites bigger than 16 by 16. So if we've got a 32 by 32, we're going to split that into 2 sprites wide and 2 sprites tall. Now, because of the way the sprites are chained, do I have a picture of that? Not on this screen. Because of the way the sprites are chained, we go down one side and then we go down the other. So what we would need to do, if I just get, where is it? Sorry, just bear with me a second. If we have a look at Paint here, and I do some amazing graphics work, if you think of your sprites as being squares like this, let's pretend that's square. So if we're doing a sprite that is 24 tall and 24 wide, for example, that will be made up of 3 hardware sprites, each of which is 3 tiles tall, like this. So that's our second sprite there in magenta, and then in cyan, here's our third sprite. So we would create these 3 hardware sprites with 3 tiles each. Now when we export this file, we want to go down this sprite in this column order, so we go down and then across and down, then across and then down and across. But because of the way the sprites are actually split up themselves, we would want to go down here and then down here and then down here and then down here. Yeah, weird, isn't it? Now, where's that window gone? And that's because of this thing here. So, and then when we're reading in these lines, we need to split the bit planes out into 2 files. So, okay, so that's what we've basically got here. So if you look here, we're working by Y first, because we're going down because of the tiles per sprite, and then we're going horizontally because the separate horizontal sprites will make up our image. And then once we're doing that, then we go into the sprite, and we're splitting that up into 2 chunks of 8 pixels, because this is 8 pixels here and this is 8 pixels here. And so we're starting at the right hand side and we're going backwards because we're subtracting 8, and then so we're doing it position 8 to 15 and then 0 to 7 here, and then we're going down the tile all 16 lines. So as I say, down here and then down here. Okay, and then we're splitting up into bit planes because the bit planes need to be separated into different files. So we're doing 0 to 3 here, 4-bit planes. That's 16 colours in case you don't know. Each sprite has a separate 16 colours on the NeoGeo. So then we're reading in 8 pixels from the screen here, from the current bank. There's multiple banks. There's 64 sprites per bank in this program. And then we're reading in the 8 pixels that are neighbouring at the current X and Y position based on the current sprite and the sprite within the entire area of the screen, which, as I say, may be more than a single sprite. So we've now got 8 pixels, and what we need to do is take 1 bit from each of those 8 pixels, depending on the current bit plane, which I've rather unimaginatively labelled P here. That's the old Amstrad CPC basic programming coming back, where we always used single letters for I for counters and things. Still do it. Still do that an awful lot. And then I've got all these functions called VBX here. Now, VBX is a class I created that it stood for something like VB, Visual Basic Extensions or something like that. Essentially, I started off programming a Japanese study game, and I wrote it originally in Visual Basic, and then I wanted to port it to C#, as I was learning C#. I'm not a professional C# programmer, I'm self-taught. So essentially, I just needed a way of getting this thing ported as fast as possible. So what I did is I wrote equivalents of Visual Basic commands that would do the same thing, so that I didn't have to keep trying to remember C# commands or remember how they work differently from what I was used to. But then I've started extending it with commands I wished I had, and this one is called dec to bin 8-bit, so it converts a decimal number into 8 binary bits. So if the number was just 1, it would still start with 7 zeros and a 1. And so it returns that as a string, and then we can take a substring and get the part we need for the bit plane. We combine all those bit plane parts into a single byte, and then we convert it back to decimal and write it as a byte. We write the first one to the first binary writer here if the plane is greater than 6. So I say plane is greater than 6. What I actually mean is the bit that we're looking at is greater than 6. So this is left to right. So the rightmost bit is bit 0, but in the way this works, it's bit 7. It's kind of backwards because it's working left to right as a string. So anyway, if we're using bit plane 0 or 1 here, then we want to save to ROM-C1, and ROM-C1 is being pointed to by this binary writer here. Otherwise, then we're pointing to ROM-C2. So there we go. Now, I will explain why I'm using Visual Studio C# 2008 here. I'm fully aware that there's much newer versions of Visual Studio. However, they keep changing the license. This version of Visual Studio you can install without a license key. 2010, you had to ask permission to install it. You had to ask permission for a license key, and they've done all kinds of crazy things since, and I've given up caring. I basically am going to keep using this old version until it no longer runs on the modern machines, because if they want to play silly games with the license fee, the license agreements, I'll play silly games with the versions. And when it stops working, I'm going to move to a open source version. I'll use Mono or Mono Develop or goodness knows what else. But as I say, I'm not upgrading just because Microsoft say I have to keep developing my own software. And I really find it quite obnoxious that they would create licenses where they can revoke your permission to keep using the software if they decide to not issue the keys anymore, and then you're in breach of the license. So that's why I stick with C# 2008, even though it's very old. It does everything I need, and that's all I care about. So there we go. So that's this code anyway. And then finally, we're just padding out here because of the way the XMLs work. I was padding the files originally. I'm not actually sure if I still need to do that because now I have some more advanced code to handle that. But anyway, that's how that works. So that is the save routine. And then what we now have is we also have a load routine. So if we just go here, and this load sprite, and essentially, I'm not going to go into it, it's essentially kind of the opposite. So we're reading in the bit planes, combining them together, and then converting them to pixels for the screen. I suppose it's a bit simpler actually. I wrote this a little while ago. It took a while to get working, but I tend to do a lot of the time it's a bit of trial and error, that I write the code, it doesn't work, everything comes out corrupted because I made a mistake, and I keep hacking it away until I fix it. And that's the benefit of having things to test with and see if the sprites actually work on the machines, or see if, in this case, if I can load a real sprite. Okay. So let's try something else. So what we've got here is Metal Slug. So Metal Slug, of course, is the old NeoGeo game. Now, for your reference here, it looks like we've got about 5 megabytes, 6, 7, 8, 9, 10. It's about 12 megabytes in total. That's, what's that in megabits? So that's 12 times 8, so 96 megabit. So, I mean, for your reference, the old Super Nintendo game, Street Fighter 2, they bragged amazingly that it was 16 megabit, and that's why NeoGeo laughed at Super Nintendo, but they didn't laugh so much when they didn't sell their ridiculously expensive cartridges. So, anyway, so that's what we're dealing with here when it comes to NeoGeo games, and you can see here we've got these pairs as before. Now, C1 and 2 as part of the same pair of sprite files. C3 and C4 are also part of the same sprite files. Now, these other ones will be different things. I don't know the codes, but some of them will be sound, and some will be program code and things. But let's have a look at this C1 and this C2 here. just bear with me a second here. Now, I'm going to give you the official disclaimer here. Yes, I'm using a ROM file. I own the game on MVS. I've got the arcade game cartridge, so sue me if you don't like the fact I'm using a ROM file. As I say, I don't have a ROM dumper for the NeoGeo, and I'm not about to do it just for this demonstration. So, anyway, we are going to be playing those NeoGeo games. This is essentially a test of the streaming software, basically. What I'm planning to do later on is I'm going to get video capture hardware and better streaming computers, obviously, and I'm going to plug the machines in and play the games and chat about computing and programming and things at the same time. So this is a bit of an early thing, but we will see that game in action a bit later. So load sprite here, and let's specify this folder here and load in C1. Now, the program, in the same way as before, will actually load in a pair. So it's loading in C1 and C2, and it's doing it very slowly because this is a horrible Celeron machine. So probably never finish here. Now, what's going on there? Okay, that doesn't seem to have worked. Maybe we've got a bug. I did make some changes to this code. That's all a bit glitchy there. So load sprite 16. Skip sprite 0. Why have we got no sprites? Okay, well that was unexpected. Let's have a look. It should have at least loaded some corruption, really, because even if you gave it totally the wrong file, it would have done something. So I'm not quite sure what went wrong there. Let's have a look at. So if we go to this file format menu here, so we've got options here: load height and skip sprites, and these are because essentially we're loading in 16 by 16 chunks of sprites, so they don't essentially work. You can't just load in a file and you'll see the exact graphics you saw in your game, because it doesn't work like that. You're loading raw data, and a sprite on the NeoGeo has no valid colors, it has no valid size. It's all about the code that actually builds them together into objects. So essentially I was adding some functions to make it easier to combine them back to something that was usable. So just bear with me a minute. I added these very late on. It used to pop up a box asking for some input, and I changed it to actually use these text boxes to make it easier to run it multiple times. And I'm just wondering if I've completely screwed it up. Yes, I have. Yeah, there's supposed to be a multiplication in here. So I've missed this multiplication off my code. So instead of storing 16 sprites times 16, I was loading 16 pixels, so it's not going to go very well. Let's try that again then. Let's see if it works a little bit better this time. So for your reference, it's now 11:30 in Japan, so that's why I can only do an hour, because I have to get some sleep. That pesky thing, sleep, which we do have to take sometimes. Okay, so if we go here, NeoGeo, load sprite, and then if we load in C1 again, and it's loading up, maybe something worthwhile will happen this time. We can only hope. we could play with the please wait screen instead. What we got? I was messing around with OBS Studio, creating all of these little animations and doing these scrollers and chat logs and things. It's quite fun. It's easier than I expected. Let's put it that way. Let's say considering I use it for recording all the time, but any special effects and things I always do in other software. But very impressed really. Very straightforward to do these things, so can't complain about that. The only slightly concerning one is the chat preview. You got this sort of chat preview on the left hand side of the screen. This thing here, essentially what it is, it's a web browser. It's got a built-in web browser, and you attach a web browser from YouTube, and then it shows the web browser, and you just swap the colors around to make it transparent with CSS. So there's a template online, you can do it. I didn't work out this. Oh dear. Oh, it's not happy. I don't know what's happened there. Never seen that message before. Maybe I've annoyed it by trying to do other things on this slow machine. Anyway, the concern would be that if YouTube changed the chat screen, it'll break all the time, or that they might just make it impossible because they want to spite people. I don't know. But anyway. There we go. That's more like what we expected to see. So, okay. So let's just mess with these settings a little bit here. Let's turn off the guides so that we can see the sprites in their full glory here. So the most of this sprite is almost entirely black. So it's not much to be seen there. Now, maybe you can guess what this is though. Can you tell? Well, if I just go to the next here. Just get my preview window back into frame so I can see what I'm showing. So, I didn't even know they were there. So these look like maybe a ROM test or something. But this is the NeoGeo logo that shows every time, when it starts up, NeoGeo 330 mega Pro Gear spec, blah, blah, blah. That's the NeoGeo logo, you see. I think the 330 mega Pro Gear spec, that's actually done with the fix layer, which is the text overlay. But if we were to change this for some sprites of matching size, we could replace that NeoGeo logo with something else. Anyway, let's carry on. So, what have we got there? I have no idea what that is. Oh, that looks like an explosion. Player 1, player 2. That looks like a soldier. Now, you're probably starting to see some of the problems here. Everything's all kind of wonky. Nothing lines up correctly. And the colours are all wrong. So that's a challenge. Now we could try and fix up the colours. Like maybe we could try and fix this up by using this set palette function here. So if we change this one here, let's just zoom in a bit. So if I just click my fourth mouse button here, that moves the colour to up here, and then if I click on it up there, I can now change the colour. So let's try and make that look a bit more like a bullet. Because why not? So there we go. No, that's not right, so it needs to be brighter. So you can see we're going to have a bit of a challenge here to get this looking good. Now, what we would want to do essentially is what we would want to do is we'd want to remap all of these colours to something that realistically matched the sprite. And you've got to bear in mind that each sprite on the NeoGeo, each 16x16 square can use a different palette. So we're defining one palette for everything, and depending on how they've used the graphics within the actual game, that may not work right. You might have the top half of a man, for example, being one palette and the bottom half being a different palette, in which case, it's not going to work very nicely. So anyway, you can see there we've now turned that bullet into the right colours, and what we would want to do is go to here and do palette to clipboard, and that would save the palette in the format for my tutorials. I'm also starting to add platform-specific palettes for some of these systems. We've got palette options here, and I will start to add them as I do the super simple series for the other systems. So anyway, that's how we can recolor our things. Now, as I say though, the visually speaking, this is quite ugly. Now, what we could do, if I just close this down here, load up Krita and see how long that's going to take to start. So what we would want to do is we would want to either take all of these sprites out of AkuSprite editor and put them in a different program and then fix up the sprites in that other program, or depending on how things are done, what we can do is we can set those export options. The sprite skip sprites will skip a number of sprites from the file. So what we could do with that is we could say, well, okay, like maybe we want to skip this entire line here, where I think that's 16 sprites in total. So we would skip 16 sprites, and that would move all of these to the left. And then if we wanted to make that and that wrap, well, that looks like 2 sprites here. So what we would do is we would set the height to just 2 sprites, and we would set the skip to skip the 16, or maybe it's 32 sprites there, and that would start to align things out a bit. I'm not going to play with that up here because it's obviously taking ages on this nasty slow machine. So I have done it with my other machine when I was developing this, just tried reorganizing some of the characters to get them together, and it depends on the character how tall it is. You know, if you think of your fighting game where there's a guy standing up, he might be 4 sprites tall, but then he'll fall over and he might only be 3 or 2 because he's shorter, and they've not encoded blank sprites because of course not, why would they? Waste ROM, and ROM literally costs them money. So what we can do here is we can go to edit, copy to clipboard, and then if we do a new in Krita here, create whatever, if we just try and get Krita to use our space here a bit more efficiently, and if we just select, so if we, oh, I missed part there. So what we could do here is we select this sprite here and then create a new image with that, and then do image, resize canvas, and we just change the width to say 40 because, as I say, this is just a simple test. And then if I just copy this and paste this in here, and there we go. So I mean, that's what the sprite should probably look like. Now, yeah, I know what you're thinking. You're thinking, oh yeah, if I need to copy all of those sprites, that's going to take me forever. Well, yes, that's possibly true in that way. As the first thing is, imagine how long it took the poor person who actually drew them. Because, you know, if it's taking you longer to rip the sprites than to draw them, well, get off your ass and draw them, you know what I'm saying. But anyway, as I said before, though, the really what you would want to do is you would want to change this option here and change, let's change this to, how many sprites are there on a pane here? So there's 256 sprites in one of these panes. So that's 256, that's 512, 1024, okay, so 12 times 256 3072. So if I go here, if we set this to sprite height of 2, and then we do NeoGeo load sprite. Now, if the sprites don't fit within the 64 sprite limit of the bank, then it won't load anymore. So hopefully this won't crash us. Although I don't think this load clears the sprites, so we might have some corruption from the old import. Anyway, let's see what happens. Yeah, it's very slow, this cello one. Okay, so it does clear the sprite. So here you can see we've now only used the top 2 sprites worth of height here. So, but it looks like I've done some mathematical mistake there. That's certainly not skipped anywhere near enough, so I don't, maybe there's a bug in my code there, or maybe there's a bug in my mathematics, both very possible. So, so anyway, let's I think we need to go further on. Anyway, you can see that maybe it's not worked quite right, but you can see the principle of what I was saying, that we can alter the settings so that it will import a certain height, and if we use the correct height for the sprites and we skip everything before what we're actually looking to export, we can potentially sort out our sprites into a way that we can then reasonably use them in our own programs. I'll double check the settings. Maybe my multiplication is out on the skipping of the sprites that we don't want to import, because I was certainly expecting to have skipped a lot more sprites than that. So I think this is the metal slug from the start of the game there. Now, I mean, just in case you're not aware, of course, there's no compression in NeoGeo sprite files. They're all uncompressed, and the reason for that is the NeoGeo has no graphics RAM as such. It's essentially the tiles are all in ROM, and that's why we have to create our ROM files, and that's why the games can't do any clever like 3D animation. And well, that's misleading. It can do 3D scaling of sprites, but it can't do the super effects things like the like, you know, Star Fox and things. They can't use the processor to create new images on the fly, because it just can't do it. The NeoGeo CD can, though, because it's CD based. The destination that used to be a ROM on the NeoGeo CD is actually RAM. And if you look on YouTube, there's a video someone created which they made a demo, through some demo scene thing, and they did actually in real time produce various fractal animations and 3D and things using that RAM, because it was only the NeoGeo CD that could do that. Sort of very impressive, you know, looked very good, but I guess it's a shame that right, okay, that I've run out of sprites here. So if we go back up here, anyway, I don't cover the NeoGeo CD in my tutorials at the moment. I guess I'd kind of like to, but it's just, you get to the point where you're covering so much stuff, it becomes very hard to actually add any more. And with a system like the NeoGeo CD, you're back to the very basics of trying to figure out how to create valid files and will the emulators run them without crashing. And it's quite difficult on the morale when you go from having a good understanding of a machine to having absolutely no understanding and starting from scratch all the time. So I've been kind of just limiting myself to the NeoGeo regular at the moment rather than... So there's our cartridges. So, right, okay, I think you can see the problem here. So essentially, it looks like that one's probably correct. This one, maybe that's just a single tile anyway, because of the way of the position, you know, that it doesn't need more than one tile to show it. Those two should be together, but they've been offset by this. So what you would actually want to do is, I think you would want to essentially, oh no, that needs to be just a single one height. So that should be over on the left here, maybe. Although there should be a bit there as well. Anyway, as I say, it's difficult because you need to kind of work out how the ROM was going to show them and fix the palettes and fix the alignment of the objects. There's no way of doing it without either disassembling the ROM files, the game ROMs that would show these, or alternatively, if someone had already done all the work and there was an XML file and an exporter for those files to dump them for you. But anyway, it does look like it works in the end. Then it just, maybe my calculation of how many sprites to skip didn't work very well. So anyway, that's really what it's doing at the moment with regards to importing NeoGeo files. It can't import patterns yet. The background tile, not background tiles, sorry, there is no background tiles. It uses sprites for backgrounds. There's nothing to import from the fix layer yet. Maybe it'd be something I'll work on later, but everything I add to this, it's as required. There's a lot of like the Spectrum is far better. You can load Spectrum screens as well as save them and things. It's just because I had to do that for ChibiAkumas. So I spend time on these things when there comes a need for them. But say at the moment it's showing a lot of progress. But as I said, the thing I want to do is try and improve the code, because at the moment it's I'm as someone who sort of hacks together programs and get them vaguely working and shout, there we go, that's done. It's fine for me, but I want to try and make it more something that there's the potential other people could use, add their own functions to, or make their own alternate versions with better functions, or add their own specialist functions for their own specialist requirements. So for that, I need to start looking at doing things a little bit better. Now this is more the way I think things should go. This save grid sprites function. So what you're able to do here is this will export the sprites, but it will split them up. So like on the NeoGeo, your 256 pixel by 256 pixel sprite would need to be split up into 16 by 16 chunks. So we've got an X size here and a Y size here, but we also have a bit depth. So not only could this do this was designed for a system like the Spectrum Next, actually, not the NeoGeo, because NeoGeo is a very complex graphics format. But with the Spectrum Next and the X16 and the MSX, these all use very similar formats. So the only difference is really the resolution you need to export for, and maybe the bit depth. A system like the NeoGeo, a system like the MSX is 4-bit per pixel. A system like the Spectrum Next can be 8-bit per pixel, and this could also do the MS-DOS systems as well, because they're the same format as well, if my memory serves me correct. But anyway, as I say, it's just really, in some cases, there's code to export a full screen and a code to export a 16 by 16 tile, but the functional requirements may be identical or virtually identical. And so it would be much better to use a single function and also get better code commenting in, and maybe better label names, better variable names. But at the moment, as I say, it is what it is. I've only spent as much time as is required to get it working. But as I say, I'd like like to make it something a bit more professional, but you know, I write it in my spare time, so it often isn't that professional. But anyway, so you know, that's the program. That's what we got. That's where it's kind of going. I mean, I'm going to be continue supporting this and adding functionality for all of the systems I cover, because it's what it's not a vanity project. I develop it because I need it. So if I'm starting to program the Dragon, you know, the Dragon 32, which I am, well, I don't know what bitmap format I need to do with that, but whatever I need, I will add new functions, and if there's existing modules that can already do it, I'll add them to a Dragon section to make it clear, and if there aren't the correct functions, I'll program them up. As you can see, we've already got the old ARM here. We've got RISC OS and also Game Boy Advance, just the 4-bit per pixel at the moment, but that's not right. That's not 4-color on RISC OS. That's is it? I'm sure that should be 4-bit per pixel. The RISC OS, I'm sure I had it doing 16 colors, and unless I tried it in 2 modes. But anyway, and with the MS-DOS, I've already got CGA, EGA, and VGA. I do have a soft spot for the CGA functionality because I used to own the PC 1512, and ironically, even though I only had the black and white monitor, I used to write little games in Quick Basic, and then used to take them to school and things and show them off. And I always use the CGA graphics, and there's something quite quirky about the color scheme, which is cyan, magenta, and white, or brown, green, and yellow. Very strange selection of colors, but it really gives it a very distinctive look, which I do have a soft spot for, as I say. So anyway, yeah, that's what I'll be doing as well. And the WonderSwan with its wide variety of options. The WonderSwan, if you don't know about it, I'll probably bring one on a stream sometime in the live streams, but it's a handheld, came around about the same time as the NeoGeo Pocket Color, and it uses a 186 processor compatible, so it's basically got a PC processor in it, and it's got the original had a 16 grayscale screen, and the later one had 16 color screen, or 16 colors per tile. Sorry, I think it's capable of far more than 16 colors on screen. So, yeah, if you were looking to program in 8086 for an early 8086 machine, and you wanted to do some simple game programming, maybe it's worth looking at. It's quite an interesting little machine. We'll also be looking at the TMS 9900, which as I say, that's a very strange one because it doesn't use a stack. So that's I'm not particularly excited about the TI 99 or the graphical capabilities of it, but I'm really quite interested in programming a machine that doesn't use a stack, because that's a very drastic change to the ways of doing things. So anyway, so there we go. So I'm going to close this stream down now because I'm getting pretty tired, really. So I hope you've found something vaguely interesting in this. You know, AkuSprite editor with its source code is in all of the sources.7-zip files on my website with the tutorials themselves. The versions change slightly because I'm constantly updating it, and sometimes the version's slightly old with a package. If I'm updating my 6502 tutorials, then I'll make sure that the latest version's in if the tutorials need it, but sometimes it gets a little bit out of date, but I'm trying to keep it up to date everywhere. Anyway, I really appreciate you watching this stream. If you've liked my rambling on and you want to see more of it, please subscribe to the channel. As I say, this is the very early stages with this naffy Celeron machine. I'll be getting a better machine. I'll be getting proper video capture hardware, and I'll be streaming some real machines and playing some games and talking about the hardware and programming them while I'm playing the games. So if you'd rather see gameplay than see real intense programming tutorials where I go through things in 20 minutes, then maybe that'll be some interest to you. But you can learn a lot more about computing from playing games than you probably think if you learn how to do it. I mean, I already understood the limitations of the hardware and how the hardware was being used just by looking at the games on the machines. You'll start to notice little things like the design choices the programmers have made. Oh, well, there's no background in this scene and there's a big boss. Well, there's a good reason for that. They're using the background tiles for the boss. And then you'll notice something like part of the screen scrolling really fast, but the bottom part has no background. and there's a big boss character there, but then there'll be a little bit of the boss character that's sticking over the background, and what they do is they're using a sprite for the little bit of the background, for the little bit that's overlaying the background, and you really start to see the odd things they're doing in the games, and it's like, well, there is always a reason for it. It's usually a technical reason, and it's usually they're trying to make the game look better than the limitations allow for by doing these things of, you know, using the tiles and the sprites in clever ways, or sometimes you'll have too much on the screen and the sprites will start to flicker, and you'll realize, well, I can see pretty easily the limitation of the hardware here and why they've had to, you know, like the Turtles game, there's only two players in the game, not four. Well, the hardware wouldn't allow for four, and sometimes the enemies are smaller than they should be in the arcade, or there's fewer enemies on screen than there should be in the arcade. And again, it's all down to the limitations. And if you start to count up how many sprites are on the screen, you'll start to understand, well, it's pretty obvious why the characters have been redrawn, or the boss doesn't use the same weapons, because the hardware limitations are kicking in there and just stopping them doing it. And anyway, so enough rambling. I'm going to go get some sleep. Really appreciate everyone watching this today. Thanks for watching, and goodbye.